Welcome students. Today we will take pair of linear equations in two variables part 3. In this part we learn about consistent and inconsistent pair of linear equations. Let us understand the consistent pair of linear equations with an example. As we saw in the previous video, the example of Akhila. As you know, Akhila is this. She is Akhila. She is going to a fair in her village. If she is opting to play a game of hoopla, it will cost her ₹4 per game. And if she is opting to take a ride on giant wheel, she will have to pay ₹3 per ride. Now, we don't know how many times she is playing hoopla or how many times she is taking ride on giant wheel. So let us consider that she rides on giant wheel X times and she plays hoopla Y times. But here a condition is applied. Let's look at the question. What is the condition? The number of times she played hoopla is half the number of rides she had on giant wheel. So, if she had the ride on giant wheel equal to Y, then she has played hoopla half the number of times, means half into X. So half into X, X means half the number of times she sits on giant wheel. Half into X is equal to Y. This is the condition applied. Once again, now suppose she is sitting on rides X times. You have to take half of X times, then you will get Y. It means she is playing hoopla Y times, which is half times of X. On applying this condition, you get an equation X minus 2Y is equal to 0. We have cross multiplied 2 with Y, and so we got 2Y minus X is transposed to the left side, and so we got an equation. We have discussed all about it in the previous videos. So, if you don't understand it, visit the previous video. The second condition is that if each ride costs ₹3, ride means X. So, if one ride ₹3, then X rides will cost her how many rupees? 3X rupees. And a game of hoopla is costing her ₹4. One game ₹4. So Y games 4 into Y. Now she went to the Mela with ₹20, or we can say that she spent ₹20. So she sat on giant wheel X times. So she spent 3 into X. She played hoopla for Y times. Each time 4 rupees. So 4 into Y. 3x plus 4y is equal to 20. This is the second condition. Now, using this pair of linear equations, we have solved it graphically. This also is available in previous video, how to make the table. After making the table, you will get this type of graph. And here you can see the two lines are intersecting at one point. Why it is a line? Because it is a linear equation. And these two lines are intersecting at one point. That point is 4, 2. This is the solution of our question. What is the question? How many times she played hoopla? So, and how many times she sat on rides? As you know, rides is indicated by X or Y. Guess? Yes, rides is indicated by X. So 4 is a number which indicates the number of times she rides on giant wheel. And 2, which is Y, it indicates the number of times she played hoopla. Now this was the example which shows that the two lines are intersecting at one point. Such pair of linear equations are called consistent pair of linear equations, which have only one solution. Now, how did we come at this result? There's also another method to understand the consistent pair of linear equations. Here it is. The coefficient of first equation is A1 and B1 is the coefficient of Y. A1 is the coefficient of X of first equation and B1 is the coefficient of Y. Similarly, A2 is the coefficient of X of second equation and B2 is the coefficient of Y of second equation. Once again, if we take the coefficient of X as 1 over here, then that is A1 and 3 is A2. Minus 2 is B1 and 4 is B2. Now find the ratio of A1 upon A2. Then it is 1 upon 3. And the ratio of B1 upon B2 is minus 2 upon 4. You just work out the ratios. You will find that A1 upon A2 is not equal to B1 upon B2. So whenever you get one solution, a single solution, a unique solution, then this condition will be applicable always. A1 upon A2 will not be equal to B1 upon B2, as you can see in this example. Here is the second example of the consistent pair of linear equations. In this example, you can see a girl, Romila. She's going to a stationery shop and she's purchasing 2 pencils and 3 erasers. Another girl, Sonali, is going to the stationery shop and she is purchasing 4 pencils and 6 erasers. Now, some conditions will be applied on this to make the equation. So the first condition applied for Romila is, it means the first equation is about Romila. And the condition is that she takes 2 pencils and 3 erasers for rupees 9. So if one pencil is costing rupees X, so we have to denote the cost of one pencil by rupees X. If one pencil is costing rupees X, then 2 pencils will cost 2X. If one eraser is costing rupees Y, 3 erasers will cost 3Y. And the condition is that she is purchasing this 2 pencils and 3 erasers for rupees 9. Here it is rupees 9. So the condition is applied. Similarly, guess what condition will be applied for Sonali? She is purchasing 4 pencils. So if the cost of one pencil is X, then what will be the cost of 4 pencils? Yes, it will be 4X. and the cost of one eraser is y. So the cost of 6 erasers will be 6y. And what is the condition? That she is purchasing these items for rupees 18. So 4x plus 6y is equal to 18. What do you observe in this graph? Here you can see a single line and there are two equations. Now in the previous graph you saw there were two equations and two lines, but here there are two equations and only one line. It means both the lines have coincided with each other. Now how did this happen? So to understand this, you have to understand that both the equations are equivalent. Now how can we understand that they are equivalent? Then you divide the first equation by a certain number, you will get the second equation. Here you are dividing the first equation by 2, then you are getting the second equation. Such equations are called equivalent. And if they are equivalent, the lines will coincide. And second interesting thing will be that they will have infinitely many solutions. Why infinitely many solutions? Because here, if you take any 1 point, 0, 3 are the coordinates of 1 point, for example, and you replace x and y with 0 and 3, then you will get 9 in first equation and you will get 18 in second equation. I'll explain only one example, others you try yourself. See, first replace x with 0, then you get 2 into 0, 0. Replace y with 3, 3 3s are 9, you got the solution 9. Similarly, in the second equation, replace x with 0, you get 4 zeros are 0, and replace y with 3, you get 6 3s are 18. Similarly, you can take the point 3 and 1 and replace the x and y with 3 and 1 respectively. You will get 9 and here you will get 18. Then you try 4.5 and 0. So again you will get the values 9 and 18. Now did you realize that I have taken more than one solution? And in the previous graph, the two lines were intersecting and we had only unique solution, one solution. Here I am telling you to replace one by one with 3 points. Only 3 points are visible on this graph, but you can see that there are innumerable points on this line. Infinitely many solutions are there. Every line has innumerable points. You can take any point, it will be the solution of these two equations. Now we can say, for instance, that if the cost of one pencil is rupees 3, which solution we are talking about? 3 1. So if the pencil is rupees 3, then the cost of eraser is rupees 1. 3 is to 1. And we are using this as solution over here. Then if you are replacing x with 3 and y with 1, we are getting the solution 9 and 18. Similarly, if the cost of pencil is 3.75, then definitely the cost of eraser will be 0.50. 0.50 into 3 is 3.75. The same solution we are using. In short, A1 by A2 is equal to B1 by B2 and is equal to C1 by C2. All of them are half. Now we are arriving at crucial results. A pair of linear equations in two variables which has a solution. In the first graph we saw about Aquila that lines are intersecting and there was only one solution. Such pair of linear equations are called consistent. Understand properly, they are called consistent pair of linear equations. A pair of linear equations which are equivalent. In which case we had equivalent pair of equations? In second case. What was the case about? It was about the two girls, Romila and Sonali, going to the stationery shop. And you found in the graph there was only one line. It means the two lines had coincided. Such equations are called equivalent, and for them we have infinitely many solutions. I explained you just in the previous slide that there are innumerable points which were the solutions of these two pair of linear equations. Such a pair is called dependent pair of linear equation. Why? Because one line was dependent on the other line. Note that a dependent pair of linear equations is always consistent. So here I have given you the cycle. For consistent pair of linear equations, there are two parts. Either you will have one solution or you will have infinitely many solutions. But when you have infinitely many solutions, it means it is a dependent pair of linear equation. Means one line coincides with another. And if they are dependent, they are already consistent. Consistent, infinitely many solutions, and if infinitely many solutions, it is called dependent. Why dependent? Because both lie on each other. So they are dependent on each other. And those dependent pair of linear equations are definitely consistent because they started from consistent. We divided them into two parts, one solution and infinitely many solutions. One solution is not dependent, but infinitely many solution is definitely dependent. The equations about two rails are represented over here. These are the two equations, and the solutions are shown graphically over here. Already this we have discussed in the previous video. You can see that the graph is having two parallel lines. Now what about the in two parallel lines? Do you see any solution? You will have solutions when the line intersect each other or coincident. Here none of the condition is applying. Neither the lines are intersecting nor they are coincident. They are parallel. It means they do not have any solution. And when there is no solution, such pair of linear equations are called inconsistent. Remember the vocabulary, inconsistent, and also write the spelling properly. Now, here the coefficient of x, which is a1 in the first equation and a2 in the second equation. Similarly, b1 in the first equation, b2 in the second equation, c1 in the first and the c2 in the second. Now, just find the ratio of a1 upon a2 is half, b1 upon b2 is again half, and c1 upon c2 is 1 upon 3. It means a1 upon a2 and b1 upon b2 both were half. It means they were equal. But they were not equal to c1 upon c2 because c1 upon c2 was 1 upon 3. So remember this condition. This condition is for parallel lines. Now we are going to summarize this into a table. Now let us summarize the behavior of lines representing a pair of linear equations in two variables and about the solutions. If the lines are intersecting at one point, then they are consistent pair. You already know that if they intersect at one point, it is called unique. It is having a unique solution. If the lines are parallel, then they are called inconsistent. I just now told you, remember the word inconsistent. This is applicable for parallel lines. And in parallel lines, there are no solutions. The third condition is the third behavior of line is that they can have infinitely many solutions when they are coincident. And if they have infinitely many solutions, it means they are dependent on each other. Dependent on each other means they are coincident. And coincident, having infinitely many solutions, are again called consistent pair of equations. So in two conditions we had consistent pair of equations. First condition was the unique solution and second condition was infinitely many solutions. But when did we have inconsistent? When they were parallel. So only one condition is there: when it is inconsistent, the line must be parallel. See here, the pair of lines are there, the ratios of the coefficients of x and y, and the constant term is there. You can see a1 by a2 is not equal to b1 by b2, then such lines will be intersecting lines and they will have unique solution. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, as you can see here it is half, here also half, and here also half. Such lines are called coincident lines and they will have infinitely many solutions. And the third condition, where see here you are having half as the ratio, here also the ratio will become half when you simplify it, but here it is 1 upon 3 and it is C1 upon C2 is not equal to A1 upon A2 and B1 upon B2, but A1 upon A2 and B1 upon B2 are equal. These two are equal. This condition is applicable when the lines are parallel lines. For this condition I took the example of rails in railway station. For coincident lines I took the example of pencils and erasers, and for this unique solution intersecting lines I took the example of Aquila in Mela, in Aquila in Fair. Again, I have summed up the same thing, intersecting lines, because now we are going to take sums and we are going to write these particular steps. A1 upon A2, if it's not equal to B1 upon B2, we'll write it, they are intersecting lines. If this condition is there, then we are going to write coincident lines. And this step is there, then we are going to write parallel lines. So understand these are the steps which we are going to do. I have summarized it. And the converse is also true. It means if this condition is true, then they are parallel lines. If this condition is true, then they are coincident lines. And if this condition is true, then they are intersecting lines. So vice versa. Here we are starting the exercise. The first sum is over here. As I already told you, the steps A1 by A2, the ratio A1 by A2 will be taken first. Here it is 5 upon 7. In the second step, you will take the ratio B1 by B2. Here you see the ratio is minus 4 upon 6. When you simplify it, you get minus 2 upon 3. Now we need not take C1 by C2. Why? Because here there is a common sense that A1 upon A2 is not equal to B1 upon B2. Hence it is having unique solution and the lines are intersecting at a point. So don't waste time to take C1 upon C2 if you know that A1 upon A2 is not equal to B1 upon B2. This you will understand with practice, with the passage of time. When you do many sums, that time you will not commit mistake. In the beginning you might take C1 upon C2, but with the passage of time, a lot of practice, you will understand that it is a unique solution, so you need not take C1 upon C2. Now in the second case, you see that A1 upon A2 is half, B1 upon B2 is half, and C1 upon C2 is also half. Here you have to take all the three, because here there can be one more option that C1 upon C2 might not be equal, or it is equal, but there is also one condition where it might not be equal. So you must take C1 upon C2 when should you take? When this A1 upon A2 is equal to B1 upon B2. Then you will have to take C1 upon C2 as the ratio. And then after that only you can come to a conclusion. So we come to a conclusion that these lines are coincident because this condition is satisfying. Which condition? A1 upon A2, B1 upon B2 and C1 upon C2 all are equal. Here is the third sum. Now I told you whenever A1 upon A2 and B1 upon B2 are equal, you have to find the ratio C1 upon C2 to come to a conclusion. Here A1 upon A2 is equal to B1 upon B2, but it is not equal to C1 upon C2. In the previous example, all the three were equal. When it is not equal to C1 upon C2, it means they are parallel lines and they are inconsistent. They never intersect with each other. They have no solution. This all we have even discussed in the previous videos. Here you have to find whether they are consistent or inconsistent. The same method is going to be applicable, but in the last line you have to write that the equations are consistent because this condition is satisfied. This is a condition for unique solution. This you will understand with practice. You have to practice many sums. You will understand how do we get the condition for unique solution. Now this is the condition for what? These are parallel lines. So this is the condition for parallel lines, and parallel lines are always inconsistent. Right? Parallel lines are inconsistent. The lines which are intersecting are consistent. And there's a third part about dependent lines. It means they are coinciding. They are also consistent. Dependent lines are also consistent.